Thank you, everyone, for coming today. I'm so thankful to have you all with me as we lay our dear Unit 7 to rest. I've prepared a short eulogy, if that's okay. We've gathered here today to remember, to honor, to celebrate the life of Unit 7. I knew this day would come one day. I just never imagined that it would come so soon. You know, it seems like just yesterday we were factoring and simplifying and using the zero property together. Unit 7 was just so young. I thought we'd have more time. But they wouldn't want us to be sad. They would want this to be a happy goodbye. So Unit 7, thank you for the memories, the wisdom, the new experiences, for everything. We love you. We'll miss you. And in your honor, our parting gift to you, our final class on problem solving with polynomials. Okay, let's do some math. So last class we talked about the abstract dimension of problem solving. Now we want to get nice and grounded with something like this guy. Let's get right on into it. An up-and-coming artist is having a piece of macaroni art framed and put on display at a modern art gallery. The piece itself is twice as wide as it is long and is surrounded on all sides by a 1-inch wide trim. Including the trim, the total area of the piece is 60 square inches. I want to know what the dimensions of the frame are. So give yourself 2 minutes. See if you can read through this problem again. Take it real slow, parse through what information seems useful to me as I'm building some kind of polynomial equation. Does it help me to draw a diagram? What's my variable going to be? All that good stuff. Try it out. Once you think you've got something, come back and check your work with me. Go! Okay, so let's take this nice and slow. I have a piece of macaroni art. I know that the art is twice as wide as it is long. So I know that the width is twice the length, but I'm not told what the length and width are. I, of course, need to know that if I'm trying to find the dimensions of the frame of the piece. So my variable needs to represent the length and the width. In this case, let me define the length of my piece as L, and then I know it's twice as wide as it is long, so 2 times the length would give me the width of my macaroni art. Cool. Now I know that this macaroni art, it's going to be probably in the shape of a rectangle if I'm talking about length and width, so let me draw in some kind of rectangle here, and because I've gone through that work, I'll label the length and width as L and 2L. Now I also know that around this piece, all 4 sides is a 1-inch wide trim. So let me now draw in my trim, and I know that on all 4 sides, right, all the way around, it's got a 1-inch border. So let me label that this trim has a width of 1 inch. The last thing that I'm told is that altogether, the total area of the piece is 60 square inches. If I know that, that means I need to be able to find the area of the large rectangle. How again do I go about finding the area of a rectangle? 5 seconds, go. 4, 3, 2, 1. Well, if you don't know it by now, I might want to fix that. The area of a rectangle I find by multiplying its length by its width. Which means if I want to use the area of this whole rectangle, I need to know the length and width of this whole rectangle. Well, take a second and pause here. How would I find the length of this whole side of the length, this whole side of the width? 30 seconds, go. And stop. Well, let me start with the length, my up and down. So if I'm going all the way along that brown side here, I know that I need to count up, starting at the top, right, that 1-inch border, plus that length L, and then that other 1-inch border on the bottom. So I've got 1 plus L plus 1, which is L plus 2. Same thing going across. Well, to get all the way across my painting, or my macaroni art, I need to go 1 across for the trim, 2L across for the width, and then one more across for the trim on the other side. Well, that would be the 2L plus 2 copies of 1, so 2L plus 2 is going to be my width. From here, all I need to do is slot in. I know that the total area is 60 square inches, and I know that's going to be equal to the product of the length and the width. It doesn't really matter which one is which, but we just found that L plus 2 and 2L plus 2 give us the dimensions of our big rectangle. Very nice. From here, if you haven't already solved this equation, pause, take 2 more minutes and see if you can get some values of L. If you have already, let's finish this off together. Okay, so first of all, just like last time, if I'm trying to factor, I need to start by getting rid of my parentheses. Let's do some met-wet on the right. Now 60 is going to be equal to L times 2L, which is 2L squared. L times 2 gives me 2L. 2 times 2L gives me 4L. And at the back, 2 times 2 gives me 4. One last move here. Let me combine those like terms. 2L plus L, or plus 4L, sorry, is going to give me 6L. Now, I know that I want a 0 on one side if my goal is to solve this polynomial equation. But before I do, let's be a little strategic. Look at these numbers, 60, 2, 6, 4. Remember, as a mathematician, your superpower is the ability to make things look the way that you want it to look. Is there a strategic choice that you could make here to make your life easier? Take 10 seconds, take a risk, take a chance, be creative. What do you think I might want to do here before I get my 0 on the left? Go. Okay, well, you don't have to do this step, but notice that all of these numbers are even, which means I could take my entire equation. Remember, I can do anything that I want as long as I do it to both sides. Let me make my life easier by dividing the entire equation by 2. Now, I can now go through and subtract 30 from both sides to get my 0 on the left. And I didn't need to make this choice. But when I do, notice now that this polynomial is going to have some nice, smaller, friendlier numbers to work with. Not only that, but it's going to be a quadratic trinomial with a leading coefficient of 1. Which means at the front, L squared, it's got to be L times L. That's the only way that I can get there. At the back, because that leading coefficient is invisible 1, I need 2 numbers that multiply to negative 28 and add to positive 3. Well, positive 7 times negative 4 gets me negative 28, and positive 7 plus negative 4 gets me that 3 in the middle. Very nice. All I've got to do now is do some zero property. Well, by the zero property, if these two things multiply to get 0, either L plus 7 is 0 or L minus 4 is 0. And now, just like we were doing in class, let's make this a little bit easier on ourselves. Instead of showing all of our work, if L plus 7 is equal to 0, subtracting 7 from both sides would reveal that L is negative 7. In the equation on the right, adding 4 to both sides would give me that L is equal to 4. Now, of course, the last thing I need to make sure of is, does either of these answers not make sense in context? Well, I can't have a negative length. L can't be negative 7, so 4 is going to be the value of L that works for me. So I know that L is 4, but now looking back at my problem, notice that I need the dimensions of the frame, not the length and width. So I'm going to take here the stuff for my frame, the L plus 2 and the 2L plus 2, and calculate those values. Well, L plus 2 is going to be 4 plus 2, so that tells me that the length of my frame is going to be 6 inches, and then 2L plus 2, plugging in for L would give me 2 times 4, which is 8, plus 2, that gives me 10 inches. If I wanted to be really good, maybe I'd write a complete sentence, but I know here that 6 inches and 10 inches are the dimensions of the frame around my art. Very nice. Let's do 2 more for the road. And then we're done with Unit 7. To make their neighbors jealous, a well-to-do family has begun construction on an in-ground pool in their backyard. The pool will be 6 meters long and 12 meters wide with a deck of uniform width around its entire perimeter. Together, the total area of the pool and the deck is 160 square meters. What is the width of the deck? So let me get you started here because there's a little bit of new terminology that we need to know. So the pool, it's a rectangle. It's 6 meters long and 12 meters wide. So per usual, let me start by drawing myself my diagram. Here's my pool. It's a rectangle. We're going to say it's 6 meters long and 12 meters wide. Nice. I'm told that around my pool is a deck of uniform width. So I know that there's a deck around the pool. Let me draw that in. So around my inner rectangle, I'm going to draw a bigger outer rectangle. Now, uniform, what does that word mean? 5 seconds go. If something is uniform, what am I saying about it? Go. 5, 4, 3, 2, 1. Well, uniform means the same. And I am not told what the width of the deck is. In fact, that's what I'm looking for. So let me say maybe W is going to be the width here of my deck. Whatever that value of W is, I know that it's the same on all sides. So even though I don't know the specific value, I can use that variable W here to represent the width of that deck around the pool. Now you've got everything that you need. You know the total area of this big rectangle here. Take 2 minutes, pause the video. Using our diagram here, can you set up and perhaps even solve a polynomial equation to represent this scenario? Go. Okay, let's do it. So once again, I need to know the area of a rectangle. If you don't know this by now, that's a problem. Length times width will get me the area. So I need to know the length and the width of this big brown rectangle if I'm going to find its area, or use that fact that I know its area. Well, going all the way up and down for my length. Well, I travel W. I travel this 6 here from the original length, and then I travel another W for the width of the deck. So that's 2 W's plus the 6 to get all the way across, up and down. Going left and right, well, I go a W across here, I go a 12 across there, and another W across here. So I've traveled 2 W's and then 12 to get all the way left and right across my pool. From there, I've just got to slot into place. So the area of this big rectangle is 160 square meters, and I know that's equal to the product of its length and width, which we just found are 2W plus 6 and 2W plus 12. Just like before, we're going to start by doing some net wet. So on the left, I've got my 160. On the right, 2W times 2W is 4W squared. 2W times 12 is 24W. 6 times 2W, that's 12W. And then 6 times 12 is 72. Once again, I've got some like terms here on the right that I can combine. 160 is equal to 4W squared plus 24 plus 12, which is 36W plus 72. Now, once again, quality of life choice. 164W squared, 36W, 72. Not only are they even, divisible by 2, they're all actually divisible by 4. So to make my life easier, thinking smarter, not harder, I'm going to divide my entire equation by 4. 160 divided by 4, that leaves me with 40. 4W squared divided by 4 is W. 36 divided by 4 is 9. And then 72 divided by 4 is 18. From here, just like before, I've got some nice, easier, smaller, friendlier numbers to work with. I've just got to get a 0 on one side so I can use the 0 property. So I can show that 0 is equal to W squared plus 9W. 18 minus 40 is negative 22. From here, all I got to do now is factor my polynomial. Well, once again, look at that. This guy is a quadratic trinomial with a leading coefficient of 1. At the front, W squared has got to be W times W. Let me slot those in there. At the back, I need two numbers that multiply to negative 22 and add to 9. Well, that would be positive 11 and negative 2. So here are my two factors. Using the 0 property, all I've got to do now is set each one to 0 individually. So either W plus 11 is my 0, or W plus 2 is my 0. If W plus 11 is 0, subtracting 11 from both sides, once again, I'll kind of skip this step of showing my work here. I trust that you know how to solve these one-step linear equations by now. On the right, W minus 2 is equal to 0, adding 2 to both sides. would get me that w equals positive 2. Now, these are, of course, my two answers, but I know that width cannot be negative. W cannot be negative 11, so 2 meters is going to be the width of my deck. Very nice. One more for the road, just like this guy. A home goods store called Schmed, Schmath, and Schmiond sells a rectangular hand mirror. The mirror itself is 5 inches wide and 8 inches tall and is surrounded on all sides by a frame of uniform width. The total area of the mirror and the frame combined is 54 square inches. I want to know the width of the frame. Once again, take 2 minutes, pause the video, set up your diagram, define your variables, use your area formula to your advantage. Let's see if we can write and solve a polynomial equation. Go! All right, come back, and for the last time of Unit 7, let's get her done. Okay, so reading piece by piece, this first sentence is not particularly important for me, other than the fact that my hand mirror is a rectangle. It's 5 inches wide and 8 inches tall. Let me start by drawing my diagram. So I've got my mirror here. We're going to say it's 5 inches wide and 8 inches tall. Of course, this is not to scale. I'm not an artist. I'm a math teacher. Now I know that I'm surrounded on all sides by a frame of uniform width. Just like before, I'm going to surround my inner rectangle with a larger outer rectangle. I do not know what the width of the frame is. It's what I'm looking for. So let me once again use W. You could use F for frame if you want. It doesn't really matter. But the width of my frame is going to be represented here by some variable W. If I want to be annoying, I'll even write next to it that it's going to be in inches. Cool. From here, I don't know what that width is, but I do know that it's the same on all sides because it's uniform width. So I've got W's all the way around. I know that the area of my mirror and its frame is 54 square inches. Once again, I know that the area of a rectangle is found by multiplying its length and its width. So I need to find the length and width of this big rectangle. Well, to get all the way across, up and down, I go W across, plus that 8 inches, plus the W again, so there's 2 W's, plus the 8 from my mirror. Going across left and right, well, I've got a W here, plus 5, plus another W over on the other side, so there's 2W plus 5. All together, I now know that my area is 54. Slotting everything in, that tells me if I multiply that length and that width, which I just found to be 2W plus 8 and 2W plus 5, I should get 54. And from here, it's all familiar. I'm going to do some met-wet over on the right. Well, 54 is going to be equal to 2W times 2W, which is 4W squared, 2W times 5, which is 10W, 8 times 2W is 16W, and 8 times 5 is 40. Over on the right, let me combine those like terms. 54 is going to be equal to 4W squared plus 26W plus 40. Now, once again, quality of life choices. It would be really nice if I could divide everything by 4, but 26 is only divisible by 2. Because all of these are even, though, let me go ahead and divide my entire equation by 2. Doing so, I now know that 27 is equal to 2W squared plus 13W plus 20. All I got to do now is get a 0 over on the left so I can factor. So I've got 0 is equal to 2W squared plus 13W. 20 minus 27 is negative 7. And would you look at that, we've ended up with another quadratic trinomial. Because its leading coefficient is not 1, I need to do a little bit of trial and error here. At the front, though, 2W squared has got to be 2W times W. At the back, the only way I'm getting negative 7 is either 7 times negative 1 or negative 7 times positive 1. In this case, the option that will work for me should be 2W minus 1 and W plus 7. Let's check our middle term here just to make sure. On the outer, 2W times 7 is going to get me 14W. For the inner, negative 1 times W gets me negative W. 14 minus 1 is the 13W that I want. All I got to do now is take each of those factors and 0 property it. So 2W minus 1 could be my 0, or W plus 7 could be my 0. If 2w minus 1 equals 0, first of all, adding 1 to both sides, 2w equals 1. Dividing both sides by 2, w could be 1/2. Or on the right, w plus 7 equals 0, subtract 7 from both sides, w could be -7. But, of course, we know that we can't have negative lengths, so 1/2 of an inch will be the width of my frame.